Okay, folks, hi. Good evening, and thanks for joining us. Yes, I did hit record. Thank you, sweetheart. Okay, because that's a reminder that the first time we did this, I forgot to push the record button. Okay, so welcome to our fifth web chat. This one's really going to be focused on the update in terms of the delivery dates and where things are and where things are going and what the next few steps are. I'm going to jump right into that, and then we'll open it up for questions. And I think Troy is here. He's going to join us and talk about some of the interesting options that we'll have coming along in the future. All right. I'm sorry. Somebody say something? So updates. For those of you who've been asking about the heated bed, that big thing, those orange things are all heated beds. Those are very, very big heated beds. For scale, that's a normal size pallet. Okay, so those are the 24-inch by 24-inch heated bed. The black rectangle you see there are the X-rays. I'm going to try later on in the talk. I'll show what they look like. That shows you the inside of it. They're pretty slick. So these are custom heated beds. We also have the controller in. It's currently sitting in the lab, having the software written for us. I was hoping Leon Kaufman, who is the team member here that is working on the software for the heated bed, would be able to join the call, but at this point he's stuck in traffic somewhere in central New Jersey. We had a very nice visit out to Bay Area Maker Faire. The machine survived, as Dan will testify just a couple minutes ago. It was printing, whatever the heck it was printing. Here are the milestones that we identified the last time we had this conversation. We said that we need to get the place rented, we need to raise the additional dollars, and we need to place the hardware orders. All of those things happened within a fairly close approximation of the dates we were hoping for. Some of them a little bit earlier, some of them a little bit later. Here is going to be our manufacturing facility. This is 5,600 square feet. We are moving in now. There's a bathroom back there. And our servers for our website are going to be over there. And we get nice fiber connection from our friends at Verizon here. So later on, as the machines start showing up, you'll see how it's all set up. But basically, that far corner over there is going to be where the big machines are going to be. Over there by the bathroom is going to be our router tables and small mills. And then over in this area is going to be the assembly area where we're going to have 15 positions where machines can be assembled, 15 to a batch. And then this entire space will be partitioned with stacks and stacks of inventory and other things like that. And I don't know if you can really see, but this is kind of our workspace. There's a couple of space for me and a space for one other engineer here. That pile of cardboard will go away. There'll be another workspace there for a couple more engineers. So, the rent deal happened, and it happened in reasonably good time. So we're pretty happy about that. The second milestone we had was to raise additional cash. Just to remind everybody, we were originally promised leases on all of our major equipment. Those leases fell through. That's what cost us the first 2.5 months. Since that time we went out, we raised cash. The cash is in the bank. In fact, some of it's already been spent. And so because the third milestone was to get all of the orders. And you know what? This camera is like way the heck up there, and it looks like I'm looking down somewhere. So I'll just bring it down here so I can see that. Guys, I'm looking at you. Okay. So then we placed all of the hardware orders online. In fact, the very first hardware order, which you see in those boxes right there, those 3 cardboard boxes next to the crate Those are the components of a small CNC mill from a company called TAG. That's already here, and it's going to be set up probably at the end of the next week. We have two of our engineers, they're senior engineers, are coming down from Toronto next week, and they're going to work on setting up the mill, and we're going to start actually production of components for the extruders probably the week of the 25th, if everything goes well. But certainly by the end of the month, we're going to start collecting up inventory for the extruders. We found a lathe that we wanted. It's a small CNC lathe called the GT27. We found one in Massachusetts in really good shape. On the 18th, I'm going up there to inspect the lathe and hopefully to close the deal, which will give us the lathe here by end of June and in operation in early July. So that will allow us to start production of some of the other components for the extruders. The next machine we have is the router, the big CNC router that we're going to use to cut the extrusions for the machine and cut the coroplast for packaging. And that is, all the parts have been ordered. We're waiting for the parts to be delivered so we can put it together here. We should have all the parts here in June. There's a little uncertainty because not all of the vendors have given us the shipping dates, so we're not 100% sure of that. Typically, these components are going to come in about the right time to be able to be put together in early July, which really brings us to the biggest bit of bad news. When we originally talked to Haas, they told us the following: 4 to 6 weeks to get the mill shipped to a rigger here in New Jersey, 2 more days to get that installed here, and then they come and they take care of it and they get everything set up. So total, absolute worst case, 6 to 8 weeks from order to making chips. When we put in the order, we didn't hear anything from them. That was when we were in San Francisco on the 15th of last month. When I came back, we started making phone calls. And what we heard back was something else entirely. We were told, oh no, we didn't mean 4 weeks. We meant 10 to 11. Our current ship date, as far as we know, is July 22nd. Sorry. If that turns out to be true, the shipping across the country, because the machines are made in California, the shipment across the country should take less than 10 days. So on about the 1st of August, the mill should be here at the riggers in New Jersey. All said and done, we should be able to start making chips by 8/10. That is really the whole hole in the tent. If we are able to utilize the machine by 8/10, all of the other machines will be online by then. Some of the inventory of the parts will have been by then. And we can really start cranking out the pre-production batch and then the production machines. So at this point, the first production machine should come off the line, be assembled, and ready to go in the last few days of August. All of the orders after that will get spaced out at about 2 per day. So net-net, the original start was going to be end of May. At this point, it's going to be no earlier than end of August. I apologize for the delays. At this point, this is the best that we can do. There is one other uncertainty, for which we cannot yet put a number to it. When we started going for the permits on the space, the township initially approved what we were doing. Currently, they're saying, yes, your structural plan is fine. Yes, your electrical plan is fine. But your egress and safety plan requires a second exit. They came up with whatever the numbers are that says, no, you can't do this, you have to do some other thing. So Friday morning, I have a meeting with the architect and with the landlord, and we're going to go over the options that are available to us to satisfy the township requirements, and we'll figure out what the solution is, how to address this, and how to get this past the township. At the moment, it looks like they will let us operate anyway, because they will give us what's called a contingent certificate of occupancy, a CCO. If the CCO gets granted any time before end of July, we should have no problem meeting the initial production startup date. If it gets past July, we could have problems. We'll know more about that probably when we submit the revised plans. I'm really hoping still this month. So that gives the township 5 to 6 weeks to give a yay or nay on the whole package, and then we'll go from there. That is really the update. Before I go on to sort of plans and next milestones, Dan, do you have any questions? No, you're good? All right. Jeff jumped off, but hopefully we'll see. Oh, Troy's back. Okay, good. So here are the milestones. I want to have the lathe here in June. I want to have the mill, the big mill, I want to have the small mill operating in June, right? The TAG. I'm making marks for myself here. I want the router operating in July. I want the big CNC mill operational in mid-August, and therefore pre-production in mid-August, and then production in late August, early September. That's kind of the plan. Do you have any other questions, Dan? No, you're good. All right. So we have a guest here, a gentleman named Troy. He is from a company in Pennsylvania that does a process called hydro dipping. And since he is right here, I think what I'm gonna do. Oh, Matt, you guys are both here. Excellent. So since they're here, what I'd like to do is have them talk about what the process is, and go ahead, guys.
Good evening, Ben. How you doing? We just got the cam working there, and we'd like to say hello, and glad to see what you guys are doing down there. I understand with building permits, I built log homes and did custom log homes for 23 states for 23 years in just about every state, so I can relate to building permits and delays.
Yeah.
With Hydrographics World, we'd like to bring your actual units to a whole new phase of a finished product. And I believe in the email I asked for you to send a package of some type of frame unit that you would have. That way we can get it back to you. You can touch it, feel it, and understand what we do here at Hydrographics World. We were thinking of a couple different options for you guys. You guys have the big aluminum look. It's sturdy. It's industrial. We were thinking maybe of a carbon fiber or a a flagpole. We have a really good pattern now, which is actually the American flags being made right here in Princeton, New Jersey. That's something to be proud of.
Troy, can I interrupt you for a second? Can
Sure.
you, even for my sake, but also for Dan and Jeff joined us again, for our sake, can you please go through and explain how the hydro dipping process works?
Sure. What we do is, let's first explain the frame unit. If you have an aluminum frame that goes all the way around your unit, we would actually take that frame, we would prep it in our shop, then we would apply a coat. And hydro dipping it's in a water-based H2O film. It's an actual poly-based film. And we have big tanks. We actually submerge in the tank through the film the pattern that lays there, and it applies and gets put on your product as an ink product. And then we cover it with like a door coat industrial, what we do military helmets for. We do rifles and guns. It's a real hard clear that we do on there, and that actually will have the exact film that you want on, or the print that you want on your actual product.
So it's a way of decorating the outside of a machine as an option.
That is correct. The appearance of the machine itself.
And there's a selection of different images that somebody can choose to have applied to their machine to make it look great.
That is correct. We have over 3,000 films just on our website. You can go through our patterns. I think on our top 500 that you can page right through, and you can see the marble finishes. You can see everything you'd like to see in the film pattern section of hydrographicsworld.com.
Did you do me a favor? Could you please type that into the chat window so that it becomes part of the record?
Sure.
So as I promised, at some point, okay, great, thanks. At some point, what I will do, probably maybe later on this week, I have some of those aluminum extrusions in the shop. I'll clean one off and I'll send it off to you, and to put on it, and we'll see what it looks like.
That's perfect. Matt, can you turn on the light for a second, please? I'm going to turn on the light, and I'm just going to show you briefly a couple things of what we do. Okay. Through this is a film. This film is a poly-based film. It's almost like what you actually cover your grocery, your leftover plate with at dinner. And this has an ink pattern on here, which I don't believe you can see at this point. There you go. You see that carbon fiber pattern?
Yeah, it does look like carbon fiber lines there. Okay.
Yep, that's carbon fiber. What we can do is we can put any color behind that and make it any color from black to white to gold, silvers. Just like a four-wheeler, like an ATV front end that we have here. We've done that in camouflage, and then we did a couple water drops here in the center just to show you how we can different sections of the hydro dip.
Okay.
Okay, and that's the process. What I'd like to do is at least show what your company can provide on the market.
What do you guys think, Dan and Jeff?
That sounds pretty interesting.
Okay. Dan, do you guys have any questions or feedback on this? I know, Dan, you don't have a mic, but you can just type things in the chat.
I missed the first part of it. My computer rebooted, so I kind of caught the tail end of the graphics part of it.
But did you get the explanation of how the process works?
Yeah, about the dipping, yeah.
Okay. I don't know if you guys have any experience with this technology before, but
I've seen it on TV where they actually put camo patterns in and you drop it down in there and you pull it up. It does a lot of complex curving. You're able to put that pattern on there and it will stay very well. You don't have any wrinkles. So I'm kind of familiar with the process.
Precisely is what it does. We can cover just about anything paint can cover. It's in 3D animation that we can wrap around and get parts covered and give that the appearance.
Well, I in particular, I kind of like your American flag pattern So I'm thinking for my own personal machine at home here, I'll probably get that done.
Okay.
Now, what on the 3D Monster will be coated like that? The frame or?
My first. I'm sorry. Go ahead, Ben. What do you have in mind?
What do you mean, Jeff?
What exactly are you going to coat with that covering? Would it be?
Well, I'm going to do the outer frame, the gantry, gantry
okay.
and the main bridge.
I got you. Okay, I'm with you.
And maybe the cross extrusions on the bottom. 'Cause I don't know if you can see, but you know, there's this cross shape right here.
Yes.
I'll probably get that covered up too. So, because I like that. I actually I got really excited when Troy and Matt got a hold of me a few weeks ago, because I think it's, you know, it's kind of cool.
Right on our website, we have some basics that you can just go to our website. We have like 6 videos up, and it just shows some before shots. It shows actually how we do roll techniques and what we actually apply it to. So you can check out the videos of us actually hydro dipping products. My first suggestion to you, as far as the frame being dipped, the exterior of your frame, how it comes across on the 3-dimensional, that is something that is, you see that bulk, thick, real heavy duty aluminum there that you have for your frame system, for your whole extruders that, you know, it surrounds the extruders. That was something I would really consider hydro dipping.
Yeah, that's what I'm looking at.
Okay, great.
All right, great. Thanks a lot, guys. Dan, Jeff, if you guys have any other questions?
I'm good.
Yeah. Talk about that?
I do have one more question, if I could.
Go.
You say that you're at this point you're almost ready to go to late August, September for production. Am I correct on that?
That's right.
Now that's when you're going to start fulfilling orders for Kickstarter, or you're going to go into production for stock.
I think it's going to be a while before we get to the point where we can do production for stock. All of our production is going to go to Kickstarter and to pre-orders. Folks have been putting in pre-orders at a fairly decent rate since the end of Kickstarter.
Okay.
At this point, we have more machines on order after Kickstarter than during Kickstarter.
I believe.
My guess at the moment is that machines that are being ordered now will be manufactured sometime in late September, early October.
Okay, so you would fair to say that you're going to be in production here by the new year.
A lot sooner than that.
Okay, great. So as soon as we get some type of part that you send to us, we're actually going to hydro dip it, and I'm going to actually drive it back down to you and meet you, because we are interested in the T-Rex, the 18. So we'd like to come down to your facility and actually bring that down and see what you're doing and show you who we are.
Sounds awesome.
Okay, I appreciate you very, very much for including us in your meeting this evening.
Great. And I actually have a couple of other things that I wanted to share with you guys. Two other things. One is that we are working at this point with 3 different filament manufacturers to try to get some interesting filaments for our customers that are not yet widely available. One of we're going to try to get some very high thermally stable filaments like PEEK to print. We're also working on getting filaments that are filled with carbon fiber to print as well.
Yes, that is what I want to hear.
Mm-hmm. Okay. So we've had a couple of folks come to us and say, well, we want to, so let me step back a little bit and explain sort of what we can do now and what we cannot do now. Those of you guys who've ever worked with fiberglass or with carbon fiber or anything else like that know that there's really two ways of using those kinds of filaments, right? One is you can have a long filament that you lay down in some fashion, right? Whether it's as part of an interwoven mat or you know, individual windings or whatever. And the other way is you chop it up into tiny little bitty whiskers and you mix it with a resin, okay? And there's some reasons for doing one versus the other. But the fundamental result at the end of that is that if you use just whiskers, you're getting a little bit of an advantage of the carbon fiber being there in terms of tensile strength, but not that much. But that if you try to do this with filament, with individual filaments laid out, it's really quite hard to do with a machine. The machines that do that today cost millions of dollars, okay? At the moment, the only thing we can plausibly do is work with guys that take the tiny little whiskers and put them inside of a regular plastic filament. That's the best we can do at the moment. Being able to lay down a complete stretch of filament, of actual carbon fiber filament, is quite beyond our capabilities. In fact, there's only one machine on the market that claims to be able to do that. They're about a year away from production. And so far, all the videos of their machine that I've seen are very artfully filmed because they completely and totally do not show how the machine actually works.
Yeah.
So it is not yet clear to me whether or not that's real in any fashion. So those are sort of the two big things. The other big thing for us is going to be that we're going to go to a show to the 3D Printer Expo in Seattle at the end of August. And we hope to already be able to bring a production machine with us. That's really one of the driving goals that we have, is to be able to do that. That's really all I have.
Will you be at Makers Queens this year?
In New York?
Correct.
Oh, absolutely.
Yeah. I was there last year. I didn't have any time to myself. I walked around and seen all the booths once, and then I was back at my booth.
Yeah, I never got a chance to see anything.
Yeah, it was hard.
Yeah.
It was real hard, but it was nice. There was a lot of neat exhibits there.
Yeah, in New York, at least we had like 4 or 5 people there, so there was some chance of, you know, getting away. But in San Francisco, I was there by myself. Because our West Coast guy, who's supposed to have come out and helped us out, you know, would have been wasn't able to make it. So, yeah, oh yeah, I just noticed, Matt. That's a nice shirt.
You want one?
You got one?
I got a box of them.
You got a box of them? Where'd you get a box of Tesla shirts?
I make them. I had templates for them. I had them made for the Kickstarter.
I think you got another customer one. Dan wants one.
Yeah.
Well, Dan, send me an email and I'll forward it, or you can probably reach Matt out through hydrographicsword.com. At the moment, we are printing with PLA, HIPS. We've tried PET. We've tried PVA. We've tried NinjaFlex. What else we tried? I don't even remember all of them.
Have you guys done chocolate yet?
No, that's still down the road. We still plan to have a paste extruder, but because of the delays in getting the production up and running, all of our product development schedules are also moving further down the road. Some of these materials we've had really good success with. Some of them less so. In particular, obviously with ABS, until the heated bed comes online and we're able to keep the platform heated, we can extrude it. It comes out of the extruder beautifully, but it doesn't, and then it sticks, but it then warps off. So I had, I don't know. So we tried printing with PET, and it worked out well, but then it lifted right off. So we're waiting for the heated bed to really be able to do full prints of any of these other materials.
And you'll keep working through that, I mean, through and getting that out to all your customers?
The heated bed will come out before production.
Okay.
That's pretty hot.
Hi, Ty. I think we have another gentleman here. Hi, Ty. We're a little bit late, but by the way, Ty, just for everybody's benefit, this whole thing has been recorded and will be stored in the archive. So if you missed any part of it, like Jeff, I know your machine crashed, you'll be able to just look it up if there's anything there that you want.
Okay.
And yes, the bed is likely to be, the bed is not going to be limited by hardware too much. So it's being designed to do, I think, about 70 C or 80 C. So we should be okay there.
Did you say 70 or 80 C, Ben?
Yeah.
Is the title go? ABS is going to need at least probably 100 to 110 for it to stick properly.
Well, I think we're going to have the power to go higher if we want to. It's going to be a software setting.
Okay. Yeah, you're not going to get ABS to stick flat, especially as big as that machine is, unless you hold it at 100, 110 degrees Celsius. So that'll work.
Yeah, there's not going to be any real hardware limitations on it other than the power supply.
What kind of power supply does run this? It should be
110 AC.
It's an AC. How many amps? How many amps does the T-Rex, the 18, draw?
The 18, I don't have the numbers for. We did the budget for the 24, and the 24 with all 16 segments going full tilt, and the printer itself going full tilt will chew up most of the 15 amp circuit.
Okay.
Gotcha.
Yeah.
Okay.
That's not
Okay,
bad.
the 18 will be less.
Okay. And that all depends on how many extruders you're running at one time.
Actually, by far the largest consumer of power, by it's more than 60%, is
Okay.
Is the what?
Is the what you cut out?
the heated bed.
Oh, the
Heated
bed.
bed.
Yeah. Okay. Yeah.
That is the bed runs directly off of AC.
Okay.
Okay.
So it's pretty much.
Everything else is
Yeah.
DC. Everything else in those, yeah.
Okay.
I mean, the cartridge heaters on the extruders are 40 watts.
Okay.
Everything else is less.
Okay.
Even the big NEMA 23 motors are less.
Wow.
Okay. So all said and done, you know, it's the bed that's going to chew up all of the power, really.
Maybe all the, yeah.
Ty, what do you mean? What's the max? Which Ty had a question. What's the max? What's the max of what? The heated bed is as in what's the highest heat setting. So our original thought was keep it around 70 or so, because that's kind of what a lot of folks are saying is a good number. Jeff makes a point that it needs to be much higher than that, like 110. So I don't know, whatever. Frankly, it has the power to go much higher than 110. The only reason to keep it lower is for safety, and for power consumption. But basically, we're running it from AC, so it can crank. Just in case, I don't know if you guys all you saw, but I'm going to go grab one. I'll be right back.
What you gonna grab? A bed.
This is a pad. Okay. It has, this one is for the 24-inch printer. I'm trying to show you.
Oh my God.
So it's got 16 6x6 segments. Okay? Each one, it has 2 power wires, and where you see a little hole right here, in the actual prototype that's in the lab, there is a thermistor there. Okay?
Okay.
So each section of the pad is controlled individually. The prototype we currently have in the lab has a controller that's plugged into all these wires, and all of the thermistor wires. And and this side is adhesive. And then there's also an aluminum heat spreader plate that's about, I think, 1/8 of an inch, maybe even a little bit less. That's between the glass and this pad. In theory, you could print directly on the aluminum plate if you really want to. Or you can print on the glass that's going to be sitting right on top. And is the surface actively monitored temperature-wise? Yes. Is it zoned by segment? Yes. Each segment has its own PID controller. So there will be a custom M code that you'll be able to embed in your G code, right? Most slicers will let you put in some custom code at the start of the file. Repetier host does that, for example. You just program it. And in that code, you'll be able to say something like, M225, here, I'll type it in. You'll be able to say something like this. M225, 100. And that means turn on segment 1 and keep it at 100 degrees. Well, segment number 12 and keep it at 70. Okay? And that's really the extent of what you're going to need to deal with a heated bed. We will probably also provide support for the standard language where the heated bed currently in all the current printers, there's an M code for the heated bed. The problem is that M code does not have the ability to have a segment number associated with it. So we're not sure whether we're going to do our own M code, or whether we're going to use their M code, everybody else's M code, and just tack on an extra parameter at the end. We could probably go either way. Okay. Question from Ty, and this goes hand in hand with individual temperature control per extruder. Correct. Yes, absolutely, positively. In fact, that's one of the reasons why we're also hacking up the Marlin firmware pretty severely at this point. I think we've at this point touched just about every single file in there. It's turning out that supporting multiple extruders correctly is a bit of a job that we did not anticipate is going to take quite this much. We're working on it. Okay, other questions? Have you gotten all 4 extruders to work at once? No, I have not. The current Marlin software does not support this. And that's what we're working on.
Okay. You have 2 extruders working at this time?
I've had 2 extruders running at the same time, yes.
Okay.
But Repetier supports that in the software. That's standard.
Repetier supports 10 standard. Slicer supports up to 4 standard.
Yeah.
But Marlin doesn't. Marlin supports 2, but it supports 2 in an ugly way. It assumes that you only have 1 fan for all of your extruders. We have 2 fans on each extruder. We have 1 fan that's cooling the hot end, and we have 1 fan that's cooling the motor. Okay? We will probably end up with a 3rd fan at some point that blows down below the part. But Marlin only supports 1 fan, period, at all. That's been one of the really painful parts about it. So much so that we, on and off, we considered jumping off of Marlin and going to Repetier firmware. I'm reluctant to do that because of how much time and energy we've invested into understanding Marlin and modifying it to do what we needed to do. But if we have to, then that's what we're.
Are you? I got a question about pretty much like Kickstarter and thereafter with the people that are doing the pre-orders. Are you finding them more East Coast, local, or are they abroad across every continent? West Coast, as far as the states go. Where are most of your extruders getting sold to?
So it's worldwide.
Worldwide? Okay.
We literally have 2 machines from Kickstarter going to La Paz, Bolivia. We had one guy just recently ask us to ship a machine to Lima, Peru. We have a couple going to Australia and New Zealand. We have a couple going to the UK, Norway, France. Hi, Dan. The other Dan that we have. If he listens in on the conversation, Dan Chetfit. He's a pretty well-known architect in France. Famous actually, which is kind of cool. We have. I said Norway, right? Norway, Austria, Switzerland. At some point we should have a map of where all of our folks are.
Mac ships out every day.
Let me tell you, you'll get a lot of dots on there real quick, man. You will.
I'm good with that. We're making the facility here with the addition of a couple of more machines. This facility was originally planned for 5 machines a day.
Okay.
We were planning to do that based on what we were told we were going to be able to get the leasing for the equipment. That didn't happen. We raised some cash, but we raised less cash than it would have been necessary to come up with all of the possible machines to get to 5 printers a day. At the moment, we're going to be about 2 printers a day. With an addition, once we get a little bit of revenue, we'll plow that back into expanding our production. Hopefully by the end of the year, we'll be able to do 5 printers a day.
Okay. When I look at your printers, I think more industrial printer on a small scale. When I do look at everything across the board at other printers, let us hydro dip a couple of them for you, and I promise you that people will look at your printer not only for the appeal of it, but it'll justify the price increase too.
Well, I think the way that I want to do this, Troy, is I want to give that as an option to all of our customers.
Okay.
And do this on an individual, customized basis, because I really want folks to pick and choose what they want to do.
Okay.
So I want to, with like 2 or 3 packages that we can figure out would make sense, and then have our customers pick that as an option. Just like today, they pick an option of 2, 3, or 4 extruders, and in the future they'll have an option of, they want to have, 2 filament extruders and 2 paste extruders or something. I want them to also have the option of, and then, you know, you can have a hydro-dipped frame.
You have actually the clause you put in there, you know, choose A, B, C, or D, you know, of different films for your finish of your product. It's customized to them.
So something along those lines.
Okay.
At the moment, I believe we have somewhere between 40 and 50.
Okay. Wow.
Ty, you had a question. Marlin would also be able to support third-party slicers. Absolutely. Marlin doesn't care how you slice it. You can slice it by hand. In fact, for test purposes, I often write G-code by hand. So it doesn't really care how the G-code gets written. So, you know, you can, any of the slicers will be just fine. In fact, internally, in-house, so there's two reasons why I use Slicer. One is, I actually happen to like the user interface, okay? But the important part is that I'm also lazy, so I like the fact that it's built into Repetier Host. And in fact, for a lot of folks who haven't done a whole lot of 3D printing, my recommendation is, before you even get your machine, go create a model that represents what you think you're going to be printing, and then get a copy of Repetier, slice it up with Slicer, and run it through the Repetier virtual printer. Right? Repetier comes with a printer simulator, so you can do the slicing, and then you can run it through and see what your object is going to look like, how long it's going to take, how much material it's going to take, and what the process looks like. It's really an excellent way of tuning things like positioning and sizing and all of the different slicing parameters and whatnot. Cura is a very different approach. Thank you, Jeff. Jeff mentions that Cura is good also. Absolutely. One of our guys, in fact, the guys from Toronto, Ed, the extruder dude, he uses Cura on a regular basis. Cura is great because once you figure out the settings, and there's really not that many of them, really excellent algorithms for laying out that are, I think, somewhat better than some of the things. I have a bone to pick with Slicer. Slicer seems to really optimize for tiny little moves, which drives me crazy. You know, you can see the extruder do this, like, move, move, You know, Cura tends to optimize for longer paths.
Can I make a suggestion? Sometimes what I'll do, if I don't like Slicer, I'll go ahead and do my model in Cura. I'll save the G-code, bring it in a Repetier, and then I like the interface in Repetier, and I'll go ahead and load the G-code in Repetier and use Repetier's printerface. I tend to find that Cura has a better slicer pattern than what Slicer 3 does.
Absolutely. That's exactly how, when we do use Cura, that's exactly how we do it. Absolutely. And then one of the nice things about that is that you still have the virtual printer emulator available to you in Repetier Host.
Correct, yeah.
Because you can then look much more closely at what it was that Cura did. You know, for the last year and a half, I've been promising myself that, you know, as soon as I get some free time, I'll also go learn how to use SkeenForge, and I still haven't.
Don't say about I haven't tried it either. I've been doing it for over a year.
Yeah. Okay, you're welcome, Ty. Jeff, the other answer to your question is, the reason why it's estimated is because the ERP system hasn't come up fully yet. Those servers just went up about a week ago, and as soon as we get the cabinet to plug them into, which is still on its way, we're going to have like a computer cabinet, like, you know, 19-inch rack kind of a thing. And so as soon as we have that, We'll put the machines in the rack. A couple more machines are going to show up, and that's where we're going to run our ERP system. Once we have the ERP system up and running, then we'll get all the orders, all of the pre-orders, all the Kickstarter orders, all of our customer information. All of that's going to go into the ERP system. We'll actually have specific data. In fact, all manufacturing will be managed by the ERP system. We're hoping to be an economical way of doing this. Because God knows we need the help. Anybody else have any other questions? I mentioned it already, but how is the schedule looking? We had a fairly discussion at the beginning of the talk, Ty. So when you get the chance, the recording should be up in about an hour or two. You can look up at the beginning of it, but net at the moment, we think there's a good chance that the production will begin in late August. And I've laid out the milestones that are necessary to be achieved in order for that to happen. Okay, well, we've used up most of an hour, so I thank you for your patience and for joining us. And if there's no other questions, I'd like to wrap it up then.
All right. Thank you for your time, Ben.
Yep. Thank you for your time, Ben, Dan, and Jeff. I appreciate it very much.
Nice meeting you. Thank you, Ben.
Thanks for joining us. The ERP will actually not be in, Dan, just to answer your question, the ERP will not be in somebody's cloud. It's an open source ERP system we've been using for the last few months on a trial basis called Open ERP. It actually is currently in the cloud, in the Amazon cloud. I hate it with a passion. I hate the Amazon cloud with a passion. The only reason it's there is because it was fast and easy. And so as soon as I can get my own servers up and running, you bet your bippy I will have it running down here, not some other. So again, thanks a lot, everybody. And we'll probably have another one of these in a few weeks after we have a few more things to report and after we have a little bit more feedback from our township. Okay? Thanks a lot, everybody.
Thank you.
Take care.